Hello students. In the past few videos we've been looking at several techniques for factoring. Well, today we're going to put those techniques together as we look at a general strategy for factoring. So that's in fact today's topic. It's titled A General Strategy for Factoring. And actually this section is located after section 5.4 on page 283 in your textbook. And it doesn't really have its own title number, but it is on page 283 if you want a reference. Okay, I have supplied for you a worksheet, and so I'm going to go to Elmo and I'm just going to show you that worksheet so you can look at it, okay? On the worksheet it says, or it should be titled Factoring a General Strategy, and then there should be 3 basic steps to factoring, and let me just go over them quickly. The first step to factoring is that you want to factor out the greatest common factor. The second step, after you've factored out any greatest common factor, you want to then count the number of terms in the remaining polynomial. And then there's several cases. Your polynomial can either be a 2-term polynomial or a binomial, in which case you want to see if it's one of those special forms, the difference of squares, the difference of cubes, or the sum of cubes. If the polynomial remaining is a trinomial or a 3-term polynomial, you want to see if there's a lead coefficient. In other words, is there some number before the x squared or not? And then decide what method you're going to use to factor it. And then finally, you could have a 4-term polynomial that results, and if that's the case, then what you want to do is try to factor by grouping. And then finally, the third step to factoring is you always check your result by multiplying to make sure that you have factored correctly. So you should multiply your product of the factors to make sure that you get the original problem that you started with, or the original polynomial that you started with. Again, I've supplied this worksheet to you, so you should have that, and you can follow along and use that as we go to the board and work some polynomials. So today I'm actually going to take a whole bunch of different polynomials and we're going to factor them. Okay, so we're going to begin with my first polynomial, which I'm going to call example A. And example A reads as follows. It's 8x to the 6th, 8x to the 6th, plus 24x to the 5th, plus 16x to the 4th. Okay, 8x to the 6th, plus 24x to the 5th, plus 16x to the 4th. Now, following along on the sheet, the first thing you want to do is you want to factor out the greatest common factor. So begin with your numbers. What number is common to each of those terms? Well, it should be 8, so you can definitely pull out an 8. And as far as the variables go, each of these has x. In fact, it has x raised to a power, and the most x's we can take out are 4 x's. So we're going to take x to the 4th out as well. So you're going to factor out 8x to the 4th, leaving you with x squared for the first term, because x to the 4th times x squared will give you the x to the 6th, plus 3 times x, plus, and then I think you have just the number 2. And you want to check to make sure 8x to the 4th times each of these gives you the top polynomial. So we've completed our first step, which is to take out the common factor. The next step now is to look at the resulting polynomials. Well, you cannot factor a single-term polynomial any further than this. However, we have a 3-term polynomial here. Count them, 1, 2, 3 terms, or a trinomial. There is no number in front of the x, and therefore this is one of the easy ones to factor, right? So let's see if we can factor it. Can you find 2 numbers that multiply to 2 but add to 3? And in fact, that's not too hard to do. Let's try the number 2, and let's try the number 1. If we have x plus 2 times x plus 1, we should get x squared plus 3x plus 2. And don't forget about this guy here, 8x to the 4th. That is still part of your problem, so that must come along in front. And therefore, if you were to take these three polynomials, multiply them together, you should get the result that you started with. Okay, so that's the first one factored. Okay, let's look at a second polynomial then. Let's look at the polynomial 9t squared minus 16. 9t squared minus 16. First thing you want to do is you want to see if you can factor out any common factor. Is there anything common to both of these terms? Well, after a little bit of looking, you should say, no, there's nothing that I can take out as far as a common factor goes. So now, count the number of terms in your polynomial. There are 2 terms. Is it a difference of squares, a difference of cubes, or a sum of cubes, or none of the above? Well, let's see. Looking closer at it, 9t squared, well, 9 is in fact 3 squared, and t squared is t squared. In other words, 9t squared is actually 3t squared. So in fact, the first term is a square of 3t. The second term is also a square. 4 squared is 16. Therefore, this is a difference of squares. Okay? It's the formula a squared minus b squared. It's a difference of squares. And therefore, you can factor that. Remember, the formula is a squared minus b squared. 3t squared minus 4 squared, that's 3t minus 4 times 3t plus 4. 3t minus 4 times 3t plus 4, or vice versa, 3t plus 4 times 3t minus 4. Can you factor each of those any further? No. And so that's your final result on B. Okay, let's move ahead to example C. Example C reads as follows. Let's take the polynomial negative 2y squared minus 14. Negative 2y squared minus 14. So again, you should be going over these steps as I go over them. The first thing you want to do is factor out any common factor. Well, actually, you know what? Let's make this problem a little more difficult. Let's put a plus here. So everyone change this. Instead of a minus, let's put a plus. In other words, let's rewrite our problem to be negative 2y squared plus 14. Now, let's take out a common factor. Notice we could take the number 2 out of both of those terms, but we could also take out a negative 2, okay? And in fact, usually, if you can take a negative out, you want to do that. So we're going to take the negative 2 out front. And we'll be left with the first term of y squared. Now, you know that when you take 2 away from 14, you get 7. So the big question is, what sign goes in between the y squared and the 7? Well, think about it. If you remove a negative 2 from a positive 14, you have to be left with a negative 7, because negative 2 times negative 7 is positive 14. So that one's a little tricky, but you can factor that polynomial as that right there, and that's probably the best way to factor it. Okay? Let's look at example D. Example D is the polynomial 2x to the 4th, okay, plus 12x cubed minus 5x minus 30. That's 2x to the 4th plus 12x cubed minus 5x minus 30. Okay. First step is try to remove any common factor from each of those terms. Well, if you notice, there's no number that's common to each of those terms. There's no variable either that you can remove, and therefore you can't factor out any common factor. So we'll just count the number of terms we have in our polynomial and see if we can just factor it from here. You have 4 terms in this polynomial, and therefore what you want to try to do is factor by grouping, right? 4 terms means you're going to try to factor by grouping. You're going to group these 2 terms and those 2 terms together. And so let me actually spread it out a little bit so that you have some more room to do that. I'm just rewriting it, and I'm going to spread it so that put the minus 5x closer to the minus 30. And now I'm going to group the first 2 terms together, the 2x to the 4th and the 12x cubed, and I'm going to group the second 2 terms together. And what we're not multiplying here. Remember, this is still a sum of terms, so I'm technically going to put a plus sign in there. So all I've done is I've grouped 2 terms together into pairs. And now, remember, you take the greatest common factor from each separate pair and take it out. So we look for the first pair, and we say, okay, what can we take out? We can take out a 2x cubed. And what you're left with would be an x. And over here you'd be left with a 6. And let's double check. That's 2x to the 4th plus 12x cubed. In the second case, what can you take out? Well, this is one of those negatives that you want to remove. So you want to remove a minus 5, and you're left with x. You're left with a 6, because if you take 5 away from 30, you're left with 6. And what sign goes in here? Well, you have negative 30 divided or taking out a negative 5 should leave you with a positive 6. Double check. Negative 5 times positive 6 is negative 30. And in fact, this is good because you see the common term there, x plus 6. So take out the x plus 6, and you're left with 2x cubed minus 5. And therefore, you have a product of x plus 6 times 2x cubed minus 5. And if you multiply these 2 polynomials, you come back to your 4-term polynomial. Okay, let's take a look at a trinomial now. This is example E. And let's take a look at 2x squared plus x minus 15. 2x squared plus x minus 15. Now I hope you're doing these along with me and trying to guess how to factor them ahead of me. So here we go. First, try to remove a common factor, and you can't. There's nothing you can take out. It's a 3-term polynomial, and the important thing to recognize is that you have a lead coefficient. That 2 cannot be taken out. It's stuck to the x squared. Now, remember, this is actually section 5.3, okay, where we talked about factoring some trinomials. And the way you factor this is either you do it by trial and error, which is the way the book presents, or you use that special method called the AC test, or the factoring by grouping method that I showed you in one of the videos. So I'm going to use that factoring by grouping method. I'm going to take my first term times my last term, 2 times negative 15, and that gives me negative 30. And I'm going to look for 2 numbers that multiply to negative 30, but add to my middle coefficient, which is 1. Right? So let me actually write that 1 in there just to remind us that there is a missing 1 right there, 1x. So you want 2 numbers that multiply to negative 30, but add to 1. And I think the pair 6 and negative 5 should do the trick. 6 times negative 5 is negative 30, and 6 plus negative 5 is positive 1. So once you've completed that, then you simply make a 4-term polynomial. So we will rewrite 2x squared, but instead of writing 1x, we're going to put plus 6x minus 5x minus 15. And then we're going to factor that by grouping. So you're going to group the first two terms together. You're going to group your second two terms together. And you don't quite have a product yet, right? Because these are all just being added up. Take out a common factor. Here you can remove 2x, and you're left with x plus 3. And here you can take out negative 5, and again you're left with x plus 3. X plus 3 is common, so we can take x plus 3, and then take the other two terms, 2x minus 5, and that should be the factorization for this polynomial. And again, you want to check this by foiling to make sure that works. Okay? Let's compare e to f. I have another trinomial I want to give you just to compare. Okay? Let's look at the trinomial 2x squared plus 4x, 2x squared plus 4x minus 48. 2x squared plus 4x minus 48. Notice this trinomial also has a lead coefficient. However, you can also do something to that lead coefficient. Remember, you should always try to factor out a common factor first, and in fact 2 can be removed from each of these terms. Unlike the previous example, you couldn't take a 2 away, so you had to do a little more work to factor it. Here you can take a 2 out, so we're going to remove the 2, and when you do so, you're left with the polynomial x squared plus 2x minus 24, x squared plus 2x minus 24. And now, can we factor this? This is a polynomial. No lead coefficient on the x squared, so this is one of the easier ones. Two numbers that multiply to negative 24, but add to 2. What do you say? Let's say x plus 6 and x minus 4, or in other words, x minus 4 times x plus 6. So your final result, don't forget the 2, should be 2 times x plus 6 times x minus 4. Okay? Okay, let's take a look at a couple more polynomials, different types. And again, remember the steps. Factor out the greatest common factor first if you can. So we're going to take g. Example g I have for you to practice is 3x cubed plus 24. 3x cubed plus 24. 3x cubed plus 24. First step, take out any common factor. In this case, you can remove a 3 from both of those terms. You're left with x cubed plus 8. Hope you guys are having fun, because I'm having fun factoring here. So we took a 3 out. We're left with x cubed plus 8. And now you want to look at your two-term polynomial. Is this a difference of squares? No. Is it a difference of cubes? No. But it is a sum of cubes. In fact, x cubed and 8 is 2 cubed, right? In fact, this is a sum of cubes. It's a cubed plus b cubed. And we have a formula for that. And let me put it right beside here, just to remind ourselves this is one of the things that you want to have memorized. Okay? A cubed plus b cubed. Remember, this factors as follows. It's the product of a plus b times a squared minus ab plus b squared. Okay, remember, a cubed plus b cubed is factored using that formula right there. So you have x cubed plus 2 cubed to worry about. So I'm going to bring that 3 down, and now I have an x cubed plus 2 cubed. So the first thing I need to put is x plus 2, right? Because a cubed plus b cubed, the first thing is the a plus b. So x plus 2 first. And now you have your 3-term polynomial. take the first thing, x squared, take the last one and square it. 2 squared is 4, and the middle term is this times this, 2x, and therefore we factored this. And if you check, you cannot factor this 3-term polynomial. In fact, whenever you use the formula for cubes, you can never factor the resulting polynomial over the real numbers, that is. Okay, so you have a product there. And let's take a look at one more, just one more polynomial here. Let's look at example H. And maybe actually if we have time we'll look at one tricky one to leave you with, H. Okay, H is z to the 4th minus 81. Z to the 4th minus 81, okay? First thing you want to do, can you take any term out? Can you remove a common factor? No. So what's the next step? Count the terms. You have 2 terms. Is it a difference of squares, a difference of cubes? Well, it is a difference of squares, kind of disguised. The 81 is easy to see. 81 is 9 squared. Z to the 4th, well, that's also a square. In fact, that's z squared squared, right? Z squared squared is z to the 4th. So you have a z squared and a 9. So let's factor that using the difference of squares formula. That's z squared minus 9 times z squared plus 9. Z squared minus 9 times z squared plus 9. And notice now, can you factor any of these resulting polynomials? Well, actually, if you look at this one here, you can factor this one because it's another difference of squares. This is a z squared minus 3 squared. And that will factor as z minus 3, z plus 3, right? Z squared minus 9 is z minus 3 times z plus 3. How about the second polynomial there? How about z squared plus 9? Can you factor that? Well, no. Remember, you cannot factor squares if there's a plus in between. So that z squared plus 9 has to stay. You can't factor these any further, and therefore that gives you the product for this. All right. Okay. Well, that pretty much wraps up how to do factoring as far as the general strategy goes. I want you to practice lots of those exercises. Remember the 3 steps. Use your worksheet if you have to at the beginning. Pretty soon you'll get really good at it. I have a couple minutes, so let me just tell you now what we're going to do in the next video. In the next video, we're going to look at polynomials involved in equations. Okay? So this is for next time. And I just want to give you a brief look. We're going to compare or consider the following 2 equations. Let's look at 2x minus 14 equals 0. And then let's look at 3x squared plus 12x equals 0. And what's the difference between these 2 equations? The difference is this equation has an x in it. This equation has an exponent of 2 in it. This is called a quadratic equation. Whenever you have a power 2 in your equation, it's called a quadratic equation. So let's recall. We know how to solve the first equation. 2x minus 14 equals 0. If I wanted to solve this, remember, way back, you're going to use addition and subtraction principles as well as the multiplication and division principles. First thing you would do was add 14 to both sides, so you get 2x equals 14. Then you would divide both sides by 2, so you get x equals 7. Remember that? We did that before. So everyone should be able to solve that first one. Well, as far as this type of equation goes, quadratic equations, these are more difficult to solve, and you can't use the same principles we used the first time. And therefore, next time, we're going to look at solving quadratic equations, and we're going to learn the principles of solving those and the steps for solving those. So that will be section 5.5, and we'll look at that next time. So until then, study hard and call me if you have any questions. So I'll see you next time.